All right, welcome to day 2 of definition of a derivative. Using what we learned from before here, so we already finished these part of the notes. We're just scrolling down here. We're on this next part here, which find the derivatives using the limit definition by hand. It's a 4-step process. First, let's go back and note what the definition of a derivative is here. So the definition listed here is f prime of x. Remember, f prime of x is how you state a derivative, f prime of x. It's the limit as h approaches 0 of f of x plus h, which is a function when you plug in x plus h into it, minus the original function of f of x. So it's really a 4-step process here, and it's just basically a bunch of algebra here, and we're going to cancel things out that we've already practiced the last few weeks doing. The first thing we're going to do is we're going to find what f of x plus h is. Now what that means here is we're basically going to plug in x plus h in for x in the original function. Okay? After that, we're going to finish the top part of this fraction here, which means we're going to simplify what f of x plus h minus f of x is. Now what should happen here, is all terms without an h should cancel. And you'll see what I mean when I talk about that. So, because the goal is here, because as we know from our last chapter, we can't find the limit as h approaches 0 by plugging in 0 until we eliminate that h. So once we can eliminate all the h, everything without an h there, we can cancel out the h's here. We can simplify even farther and cancel out h's then afterwards. And then we can just simply plug in 0, as it says here. We can just simply plug in 0 for h, because that's what it means to find the limit, as we learned last chapter. So let's go ahead and practice this. So first, identify the function. So the original function here says, find the derivative of f of x equals x squared plus 1. And now it does say at x equals negative 3 and 2. We'll talk about what that means here first. But first, we want to find the derivative of f of x. So we want to find f prime. So in order to find f prime of x, we got to know the definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so that's what we're trying to find here. So that's the definition. But now how do we find that? Well, so the first thing we need to do is we need to understand what is f of x plus h. So in order to find f of x plus h here, we got to plug in x plus h into the original function. So notice the original function was x squared plus 1. So it was something squared plus 1. That something for f of x plus h is x plus h. So f of x plus h equals x quantity x plus h squared plus 1. Now, we need to remember a few things from our previous stuff here. So we need to remember some basic algebra stuff, meaning anytime you have an x plus h squared, that's going to come out to be x squared plus 2xh plus h squared. That's something that we're going to use a lot, so it's important that you remember it. Another one you should remember is if you had x plus h cubed. That would probably be the biggest one we'll deal with. That equals x cubed plus 3x squared h plus 3x h squared plus h cubed. And that really just comes from doing algebra if we were just to distribute over and over again. So that being said, looking at what we said we remember here, f of x itself now, f of x plus h will equal, well, x plus h quantity squared we just said was x squared plus 2xh plus h squared. Right? And then plus this 1 that comes down. So now we're going to take this function and we're going to plug it in right there in our equation. So there's our equation that we're going to plug in here. So we have the limit as h approaches 0 of, Well, now the first part here of f of x plus h, so we're going to plug in x squared plus 2xh plus h squared plus 1. That's f of x plus h. Minus now, so minus. Now we got to plug in f of x. Well, f of x is just the original function that was highlighted right here. F of x is just x squared plus 1. So minus, remember, in parentheses, now x squared plus 1. And this is all over h. So when you look at this now, we really just have to simplify. So this is the next step here. We found f of x plus h. We plug those two things in. Now we simplify. So when we simplify here, we distribute the negative, which means we're going to get a negative x squared minus 1. So when we look here now, we have x squared plus 2xh plus h squared plus 1 minus x squared minus 1. If you cancel out what you can, the negative x squared here cancels out positive x squared. Positive 1 cancels out with this negative 1. And like I said before, you're left with nothing but things that contain an h. So anything without an h got canceled. And you're left with now 2xh plus h squared all over h. Well, now we can cancel out h, right? This h can cancel out from each of the h's there. And so we're left with the limit now as h approaches 0 of 2x plus h. And if you recall from last chapter, if I want to find a limit as it approaches something, I can literally just plug in the value here. So I'm just going to plug in 0 for h. For h, notice, not for x. And so my answer ends up being 2x. So what we just figured out there is we figured out that the derivative, so f prime of x equals 2x. So now, that's the general function, general derivative. Now, if we want to find the derivative at a specific point, so now we're talking about the next step here. So it says find the derivative, and then it says here at these 2 points. All that means there is now we just plug in those values into the original function. So we have f prime of x. Well, that equals 2 times something, which is x. Well, for the first one here, we're going to say, okay, we're going to plug in negative 3. So if we throw in a negative 3, this value is going to come out to be negative 6. So that would be our first value. So f prime of negative 3 equals negative 6. If we plug in f prime of 2, which is the next one, we plug in 2 here. If we plug 2 in, well, we would get 4 out. So now what both of these are stating here is, remember, the derivative is the slope of the line tangent at a specific point. So the point we're talking about here, right here, is at negative 3. So when x is negative 3, the slope of the line tangent to that curve at negative 3 is negative 6. For the slope of the line tangent at 2 is 4. Okay? And those are the steps that we have there. So here we got a couple more examples. Next one, same thing. So again, remember, first step here, it says find the derivative. So if I want to find the derivative, right there, there's my original function. I got to first find f of x plus h. So f of x plus h in this case equals, well, it says x squared, so x plus h squared minus 4 times x, so minus 4 times x plus h, and then plus 3. Now, if we simplify this, remember the x plus h squared equals x squared plus 2xh plus h squared. If we distribute the negative 4 here now, we get negative 4x minus 4h, and then we just got to bring down that 3. So f of x plus h ends up being that. So when we go back here and we take the definition, again, notice the definition here. If we take this definition here, that's our definition. So we plug in everything that we need now. So we have the limit as h approaches 0 of, well, f of x plus h. We're just going to literally copy down everything we took here. Plug that in for f of x plus h. Minus f of x. F of x, is listed right here up above. F of x is x squared minus 4x plus 3. And this is all over h. So again, the same thing here. We're going to distribute this negative. Right? We distribute the negative to each of these right here. So now our problem that we're looking at, we're going to simplify. We're going to simplify our problem right here. So what can cancel out here? So we look. Remember, anything that doesn't have an h should cancel. So x squared cancels with x squared. Negative 4x cancels with negative 4x here. Negative 3 cancels with positive 3 right there. So we're left with only terms that have h's. The 2xh plus h squared. And then don't forget about that negative 4h that's right there. So if you look here, we got that. And then the negative 4h was left right there. And this is all over h. And the reason why we have that now is because basically we have to take out an h from each of the terms on top. So that h cancels with that and that and that. So now we're left with, ultimately, again, the limit as h approaches 0 of 2x plus h minus 4. Now remember, if we want to find the limits, the whole reason why we did all this is because we need to be able to plug in 0 for h. Now we can plug it in, so we get 2x plus 0 minus 4. And so our derivative ends up being just simply 2x minus 4. So again, that's our general derivative. So if we were to say f prime of x would equal 2x minus 4. So that's at any given function. So now the last parts here are if we want to find the value for the derivative at a specific point. So if we want to find it at x equals 5, we just simply plug in 5. So f prime of 5, we just plug in 5 for x. So it becomes 2 times 5 minus 4, which is 10 minus 4. 10 minus 4 is 6. If we want to find the derivative at negative 1, well, we plug in negative 1 then. So we get f prime of negative 1, which is 2 times negative 1 minus 4. 2 times negative 1 is negative 2 minus 4 is negative 6. And again, what that means is the derivative or the slope of the line tangent at negative 1 would equal negative 6. The slope of the line tangent or the derivative at 5 would equal 6. If we were going to ask just what the specific, the general derivative of this function was, the derivative of f of x, f prime of x, would equal just 2x minus 4. We can use that and then plug in any x value we want to find the derivative at a specific point. One more. So this one now here, working the same pattern here, but now this one just deals with x cubed plus 5. So the first thing we want to do is we want to find f of x plus h, which in this case would be quantity x plus h cubed plus 5. And now, like I said before here, we want to remember x plus h cubed. I wrote it up here. X plus h cubed. You can literally just copy this right here. X plus h cubed is x squared plus 3xh, or plus 3x squared h plus 3x h squared plus h cubed. All right, and then, but we have still this 5 right here, so plus 5 we got to bring down. Right, so the quantity x plus h cubed was that right there, and then we brought down the 5. So our f of x plus h is listed right here. So now when we plug it into the definition, so we have the limit as h approaches 0 of f of x plus h. So we have all this. F of x plus h. Remember, minus f of x now. So we got to plug in the f of x. F of x was x cubed plus 5. And this is all divided by h. Right? All we did was take the definition as we listed before. So now, we just go through our steps. Simplify. So first, distribute the negative. All right? Now cancel out whatever we can cancel out. X cubed cancels out with x cubed. Negative 5 cancels out with positive 5. We should be left with only things that have h's in them. Anything that does not have an h should cancel. 3x squared h plus 3x h squared plus h cubed. We're good there. Over h. Now, if we want to find the limit as h approaches 0, in order to plug in 0, we have to cancel out that h on the bottom. So we got to cancel out our h's. So that h cancels out that h there, cancels out that one of those h's there, changes this h cubed to h squared. And so we're left with now the limit as h approaches 0 of 3x squared plus 3x h, and then plus h cubed or h squared. So now we can plug in 0. So we just simply plug in 0 in for h. So plug in 0 right there. Plug in 0 right here. Now anything that has a 0 in it here should cancel. So this right here cancels the 0. That cancels the 0. So what we're left with then, our final answer, or our derivative, is 3x squared. So the general form of the derivative, f prime of x equals 3x squared. So if f prime of x equals 3x squared, now if we want to find it at any specific point, we can plug in that value for x to figure out the slope of the tangent line at any specific point. So here now if we plug in negative 2, so we have f prime and we want to find it at negative 2, we just simply plug in negative 2 in for x, and we end up getting 3 times 4, because negative 2 squared is positive 4, which equals 12. So the slope of the line tangent at negative 2 would equal 12. It's a lot of algebra, as you can see here. Basically, remember, just go through the steps here, right? First thing, know the formula, which is listed right here. That's the definition of a derivative. In order to use the definition of derivative, though, you first have to find f of x plus h, and you simply do that by plugging in x plus h in for x in the original function. Then plug it into the derivative, and you simplify f of x plus h minus f of x by distributing the negative f of x, and all terms without an h should cancel. And then after you do that, you should cancel out all h's. And then the last step would be just plug in the 0 in for h, notice, because we're trying to find the limit as h approaches 0. Feel free to join me on the Zoom sessions if you guys have any questions on this. Keep up the good work. We're only a week away, basically, here from finishing off the school year. So let's try to enjoy it the best we can. Hope you all are being well, and I'll talk to you soon.